Welcome to another edition of Geometry. This is Unit 4, Section 2, Medians and Altitudes of Triangles. What do you median that I have an altitude? It's kind of a silly math geometry take on what do you mean that I have an attitude? You try writing geometry jokes. They're not easy. Cool. Just cool animation. A median of a triangle is a segment with its endpoints being a vertex of a triangle and the midpoint of the opposite side. So in this picture, we have segment CD, and it is a median of triangle ABC. One of the things we would know here is if it's a median, then that makes this segment congruent to this segment. They both would have equal lengths. D would also be the midpoint of segment AB. So there's a couple of ideas that should pop into your mind when you are told that a segment is a midpoint, segment is a median of a triangle. Okay, every triangle has three medians that are concurrent. The point of concurrency of the medians of a triangle is called the centroid, and it is always inside of the triangle. And there's a very important reason for that. Okay, centroid theorem. Basically what this theorem says is the medians of a triangle intersect at a point called the centroid. That is 2/3 of the distance from each vertex to the midpoint of the opposite side. So what we would do here, let's say that this value from C to P was 6. Well, that would mean that 2/3 of a value x would be equal to 6. 2/3 of x being 6, that would be 9, right? Would be the length of the whole thing. So this would be 3, right? So you can see how we can figure out these distances based upon information they're going to give us. They're going to give us one of the values, and we're going to have to figure out the other two. Okay, so centroid physics. Why are centroids so important? Well, if you remember, I said there was a very important reason as to why the centroid is always located in the interior of a triangle. All polygons have a balance point, or what is called a centroid. And another term for this would be the balance for this balancing point is the center of gravity. So what does this mean? Well, basically, that this is the point at which the region is completely stable under the influence of gravity. Once you find the centroid of a triangle, you can take that triangle and balance it on the head of a pin, basically, and it would be stable. It would not fall off. It would be equal and balanced. So that's why we call it the center of gravity. Okay, so an altitude of a triangle. is a perpendicular segment from the vertex to the line containing the opposite side. It can be inside the triangle or outside, as is evidenced by the triangles at the bottom of the screen you'll see there. So the triangle on the left, the altitude is in the interior, but the triangle on the right, the altitude is in the exterior. It could also be a side of a triangle, which is true for right triangles. The important thing about an altitude, one of the things we look at the altitude, we use it often to find the area of a triangle, the height. We used to call it the height. So keeping in mind altitude, like as it relates to airplanes or how tall something is per se, we're referring to the height. Okay, the lines containing the altitudes of a triangle are concurrent, and they intersect at a point called the orthocenter. And the orthocenter doesn't do anything special, but it is a point of concurrency for altitudes. All right, so as you can see here, we have some orthocenters of three types of triangles. Our first triangle here is acute, and our second triangle is obtuse, and our last triangle is right. So for acute triangles, the orthocenter is in the interior of the triangle. And for obtuse triangles, it is in the exterior of the triangle. But for right triangles, that's a different story completely. This is located on the vertex of the right angle. So that's one that's very interesting. Okay, so you want to just kind of have a handle on where these are located, the orthocenters of a triangle.
That's all, folks.
Oh, boom.